Hello. In this video, we're gonna review a few exercises and problems on the second unit of the AP Physics in Mechanics, specifically on the topic of dynamics. We're gonna see a few examples on applying equations for finding the position of the center of mass, on finding forces when we have equilibrium, or by finding force from one object to another on Newton's third law, or finding any kind of forces by using Newton's second law, like finding the force of tension that is applied on an object, maybe finding the apparent weight of an object as the object is moving, or finding the terminal velocity of an object that is moving on air, or forces on objects on inclined plane. Then we're going to see a few examples of applications of the law of universal gravitation, and maybe some examples of circular motion. So AP Physics C, the second unit includes all of these chapters. It's a long unit, so let's start with our first problem, which is by finding the position of the center of mass for an object for a random lamina. Now, we remember that the position of the center of mass, by definition, is position of the first particle multiplied by mass of the first particle plus position of the center of mass of the second particle multiplied by mass 2 of the second particle, plus we keep adding the product of position times mass, dividing by the mass 1 plus mass 2 plus basically the sum of all the masses particles, so the total mass of the system. In this case, the masses are not clearly defined, but we can consider that the mass is proportional to the area. So we're gonna break this lamina into three different particles, three different objects, and we need to calculate the position of the center of mass for each object. So the first position, x1, is 1 meter, and also the y1, the y location of the center of mass, is also 1 meter. For the second square, the center of mass is located exactly at the center of the object, and we can see that the x2, it is 3.5, and the y2, it is 1.5. And for the third object, the x3 is exactly at the center of the object. If necessary, we can draw the diagonal. So the center of mass is at the position 6.5, and the y coordinate is at position 2. Now that we know the locations of the center of masses, we can spend 1 minute finding the masses themselves. So the first square has an area that it is 2 by 2, so it is 4, so we can consider that the mass 1 is proportional to 4. The area 2 is 3 times 3, so it is 9, and the area 3 is from 5 to 8, 3 times 4, so it is equal to 12. So by applying the x position of the center of mass, we have x1 times m1, which is 4, plus x2 times m2, which is proportional to 9, plus x3 times m3, that it is proportional to 12, divided by the total mass, which is 4 plus 9 plus 12, and we're going to find the value approximately 4.54 meters. So the location of the center of mass is somewhere on this line, 4.45 meters. Now we're going to repeat these calculations for the y of the center of mass in a similar way. Y center of mass is equal y1 m1, so the y1 again is 1 multiplied by the mass 1, plus y2, which is 1.5 multiplied by 9, plus y3, actually I made a mistake there, y3, which is 2 times the mass is 12. Again, the total mass doesn't change, so it is 4 plus 9 plus 12, And from this, we're going to find that the location of the center of mass is 1.66. So the location of the center of mass is somewhere on this line. So the coordinates of the center of mass are 4.54, 1.66, which makes sense. The center of mass should be under the y is equal to, because there is more mass on the bottom half of this shape, and the center of mass should be on the right side of 4, because there is more mass on the right side of the shape. So I believe that our calculations are correct. We can continue to one more application for finding the center of mass. Actually, in this case, we know what is the definition of the center of mass, what is the position of the center of mass. The question informs us that, according to the diagram, we have an object of mass 3 kgs and a stick that has negligible mass, so we don't care about the mass of the stick, but we have another mass somewhere 4 meters away from the first mass, and we know that the system of the two masses has a center of mass that it is 1.4 meters away from the first mass. So we need to figure out what is the mass on the right side. So we can consider that the 3 kgs is our first mass. The unknown mass, we will call it M2. We know the position of the center of mass. The position of the center of mass is 1.4 meters if we consider that the position 1 is 0 and the position 2 is 4 meters to the right. So by applying one more time the law for the position of the center of mass, which is x1 m1 plus x2 times m2, divided by m1 plus m2, we will know that the position of the center of mass is 1.4. It is 0 times m1, so we don't care about this term. x2, which is 4 times m2, that it is unknown, divided by m1, which is 3, plus m2. Now, in order to move on, we need to cross multiply. So 1.4 multiplied by 3 plus m2 equals 4 m2. We need to distribute the 1.4, so 1.4 times 3, this is 4.2 plus 1.4 m2 is equal 4 m2. Taking the 1.4 m2 to the other side, 4 m2 minus 1.4 m2 is 2.6 m2, and dividing by 2.6 on both sides, we bring that m2 is equal to approximately 1.6 kilograms. And again, this answer makes sense, because if mass 2 is 1.6 and mass 1 is 3 kgs, then the center of mass will be closer to the heavier object, which is the 3 kgs. We can move on to our next question, which is an application of an object that has non-uniform mass density. Now, in this case, the formula for the center of mass changes to integral of x times dm divided by the total mass, which is integral of dm. Now, the given in these questions usually is the linear mass density. Now, the definition of the linear mass density lambda, if it is uniform, it means mass over length, but for a non-uniform object, it means dm over dx. So what we do is we know the linear mass density. It is 4x, it is equal dm over dx. And what we need to do is, because usually what we know is the length, so my variable is x, so the x initial in this case will be 0, and the x final will be 8. What we need to do is change the dm inside the integrals to something that it is related to x. So basically we're gonna cross multiply and result in that the dm is 4x times dx. So we'll replace this dm with 4x dx in both integrals. So we'll have an integration instead of dm, it will be an integration of dx. Now we need to calculate these two integrals. The meaning of the second integral is the total mass. So actually we can say that the integration from x initial to x final of dm, if we replace the dm, it will be 4x dx, and if we use calculator to calculate the integral from 0 to 8, 4x dx, I believe the result will be integral of 4x, so 4x squared over 2, so it is 2x squared, and we need to replace x is equal 8 and x is equal 0. 8 to the power of 2 is 64, 2 times 64 is 128 minus 0, so the value of the mass is 128 kgs. Now in order to find the center of mass, we need to calculate first the first integral, so integration from x initial to x final, x times dm. We know that the x initial is 0, the x final is 8, and we have x times, instead of dm we're going to replace 4x dx, so this is integral of from 0 to 8, 4x squared times dx. This is 4x to the power of 3 over 3 from 0 to 8, and the value for this is approximately 682 and 82.67, so 683. Now this is not the final answer. The position of the center of mass is the value 683 divided by 128, and this results in approximately 5.33 meters away from position 0. We can continue to our next example, which is calculating the value of two unknown forces, the tension and an applied force, that keep an object in stationary position, and this means that the object is in equilibrium. Now we always start with a free body diagram in these cases, and the first force that it is applied on our object is the force of gravity. Since we know the values, we will substitute, so the force of gravity is mass times g. The mass is 500 grams, so 0.5 times 10, and the result is 5 Newton. There is a force of an applied force F pulling the object to the right, but since there is a rope, there has to be a force of tension to the direction of the rope. Now, this force of tension, unfortunately, it is applied on an angle with respect to the x-axis and to the y-axis, so we need to analyze it into two components. There is a force of tension x and a force of tension y. The given angle is 30 degrees with the y-axis, so if we need to calculate the components, we'll say that the force of tension y, it is force of tension multiplied by the adjacent, and this is cosine of 30 degrees. Force of tension y is adjacent to the 30 degrees. That's why we're using the cosine of 30 for this case. And the force of tension x, it is equal force of tension multiplied by sine of 30. So this brings force of tension multiplied by root of 3 over 2. And force of tension multiplied by 1 over 2, or 0.5. Now we don't know the values of the force of tension X and the force of tension Y. Again, it is a little bit important to have in mind that the force of tension X is adjacent to the 30 degrees. That's why the tension Y is calculated from the cosine of the angle. However, we don't know the value of the applied force, we don't know the value of the force of tension, but we know that the object is stationary, so we can use that the F net is equal 0. But since the object is stationary, it means F net X is equal 0 and F net Y is equal 0. We need to decide if we're going to start working from the x-axis or from the y-axis, and if we check what we have, our data, for the x-axis we have two unknown forces, the force of tension X, which we don't know the value, and the force F, which we don't know the value. So maybe it's better to start from the y-axis because there is one only force that we don't know the value. So the force of tension Y is equal to 0. It means that the force net Y is equal to 0. This means that the force of tension Y minus the force of gravity is equal to 0. So this means that the force of tension Y, which is force of tension times root of 3 over 2, is equal to 5. And if we divide 5 over cosine 30 or 5 over root of 3 over 2, we bring the value force of tension is 10 root of 3 over 3, according to my calculator. This is correct. And if we need to find the value of the force F, now we'll work on the x-axis. So we'll say that the F net on the x-axis is equal to 0. This means that the unknown force F minus the force of tension X is equal to 0. So unknown force minus force of tension times 0.5 equals to 0. Force minus 10 root of 3 over 3 times 0.5 is equal to 0. And this means that the force is equal 5 root of 3 over 3 Newton. We can move on to our next application, which is the force between two objects that are moving. Now we have object X and object Y that are pushed by a force F. Actually, the force F is applied on the 2 kg object, which in return, as it starts moving, it pushes the Y object. So we have the force from the X object to the Y object, and this is the action, the force from the X to Y. It has an equal and opposite reaction. We have the force from object Y to object X. And we need to figure out what is the force of object Y to object X. We need to find the value of this force. Now, we cannot find directly the value of this force because we need to find the acceleration first. And in order to find the acceleration, first we will work for the system of two objects. So we consider these two objects as one object, and the F net is equal mass of the system multiplied by the acceleration of the system. Now, the F net is the sum of external forces. The only external force in this case is the force F. Actually, we don't need to do that because we know the acceleration, but if we had to find this value of the force, this force, it is equal to the total mass, which is 6, multiplied by the acceleration, which is 4. So the unknown force, the external force F, is 24 Newton. I repeat, usually we do this in order to find the acceleration. In this case, the acceleration is given. I didn't see that. So now we need to find the force from Y to X. Now, there are two ways that we can find this. Either we'll work for object X, or we will work for object Y. Now, the easiest object to work is the object Y, because there is only one force applied on it. So if we work for object Y, we can find that the F net on the object y is equal to the mass of object y multiplied by the acceleration. The only force that is applied on object y is the force from x to y. It is equal 4 times 4. So this means that the force from x to y is equal 16 Newton. And since this is the action, the reaction will also be 16 Newton. If we decide to work for object x, we can apply again Newton's second law, F net is equal mass of object x multiplied by the acceleration, but the F net on the x-axis for the x object is the force to the right minus the force to the left. So the force minus the unknown force is equal 2 times 4. The force, we said that it is 24, minus the unknown force is equal to 8. And if we bring the 8 to the left and the force yx to the right, we will have that the force yx will be equal to 24 minus 8. It is 16 Newton. And we see that we find the same answer no matter for which object we will work. We can continue to a similar question about an object, two objects, a system of two objects. One particle is at the top of another particle that it is moving, and the force that makes the system move is a 50 Newton force to the right that is applied on the card, on the bottom card. Now, although the force is applied on the bottom object, the system is moving to the right. Both objects are moving to the right. And the reason why the top block is moving to the right is because it receives a force from the bottom block. So there is a force from the bottom card to the top block. So there is a force from the object 2 to object 1. However, this force is actually a force of friction. And since the object 1 is not moving with respect to the object 2, then this is a static friction. So there is a force static from object 2 to object 1. Now this is an action, so it will have an equal and opposite reaction on the bottom object. So there is again a force of static friction from object 1 to object 2. Now, in order to find the force of friction, first we need to find the acceleration of the system. And in order to find the acceleration of the system, we consider these two objects as one. So the F net is equal to the total mass multiplied by the acceleration of the system. The only external force is the 15 Newton force. The total mass is 3 kg and the acceleration will be 15 over 3, which is 5 meters per second squared. And now that we found the acceleration, we can find either the force from the object 2 to object 1 or from the object 1 to object 2. And so we need to find the force that the block exerts on the card. So technically the question is asking for this force. However, it is easier to work for the block and say that the F net on the block is equal mass times acceleration for the block. The F net is the static friction from 2 to 1. It is equal with 1 times 5. So the static friction between the two objects is 5 Newton. And if we want, we can say that because of action and reaction, or because of Newton's third law, the force from the block to the card, it is also 5 Newton. We can continue to our next application, which is to find the acceleration. And actually, I will add one question here. I will say also find the tension for the system of these two masses that are hung through a rope, and the rope is passing through a pulley. Now, the strategy for connected objects is, again, we need to draw a free body diagram. So we have the force of gravity on the first object, which is 5 times g, so it is 50 Newton. And the force of gravity on the second object, which is a little bit less, the force of gravity is 3 times 10, so it is 30 Newton. So actually I should have drawn the first force of gravity as a little bit longer arrow. So force of gravity 1 is 50 Newton and force of gravity 2 is 30 Newton. And there is a force of tension. The force of tension on the two ropes are equal, so actually we need to draw the force of tension just a little bit bigger. And we need to make sure that the force of gravity 1 is greater than the force of tension because the heavier object is moving downwards, and the force of tension is greater than the force of gravity 2 because the lighter object starts moving upwards. Now that we know this, we can work for the F net on the system. So in order to find the acceleration, we only care about external forces. The only two external forces are the two forces of gravity. So the F net is equal mass total multiplied by acceleration. And although both forces point downwards, the first force of gravity is pulling the system, is pulling the pulley counterclockwise, and the first force of gravity is pulling the pulley clockwise. So actually we need to subtract these two forces of gravity. So 50 minus 30, it is equal 5 plus 3 multiplied by acceleration. So 20 is equal 8 times acceleration, and from this we get that the acceleration is 2.5 meter per second squared. Now that we know the value for the acceleration, it is easy to find the force of tension. We can work for object 1 or for object 2. I think I prefer to work for object 2. So the force net is equal m2 times the acceleration. Object 2 is moving upwards, so the F net is Ft minus 30 is equal mass 2 multiplied by the acceleration. So tension minus 30, it is equal to 7.5, and from this we result that the tension is 37.5 Newton if necessary. Okay, and we go to an application for the law of universal gravitation. Now, according to the law of the universal gravitation, any two objects that have mass have an attractive force of gravity between them, that it is the constant of universal gravitation multiplied by the mass 1 multiplied by the mass 2 divided by their distance to the power of 2. And at the same time, the acceleration of gravity for an object that it is away from the surface of the Earth, it is the first part of this equation, which is capital G, multiplied by the mass that creates the gravitational field, basically it is the mass of the planet, or in this case the mass of the Earth, divided by the distance to the power of 2. So the question is finding the gravitational acceleration and then find the weight of that satellite. So first we need to use the law G is equal capital G multiplied by the mass of the Earth divided by the distance, but we have to be a little bit careful. This distance is the distance between the center of the Earth and the location of the satellite. So we have the radius of the Earth plus the altitude. The altitude is the height. Now, the radius of the Earth most likely will be given to us. Now I'm going to use the value 6.37 times 10 to the power of 6 meters. And we know that the height is 400 kilometers, so it is 400,000 meters, or 4 times 10 to the power of 5 meters. So in this case we need to add radius of Earth plus height to the power of 2. Now, if we substitute the values for the law, for the universal gravitation constant, the mass of the Earth, that it is a little bit less than 6, it is 5.97 times 10 to the power of 24 kgs divided by radius of Earth plus height. The radius of Earth, we said that it is 6.37 times 10 to the power of 6 plus 4 times 10 to the power of 5, and all of it to the power of 2. I will need a few minutes to actually calculate this. What I get is approximately 8.7 meter per second squared. And we need to find the weight of the satellite. We have two options for this case. Either we will just say that the force of gravity is mass times g, but in this case the g is not 9.8, it is less than this, so we can say 740 multiplied by 8.7. This brings approximately 4,038 Newton. Or if we want, we can apply the law of universal gravitation, 6.67 times 10 to the power of negative 11. The mass 1 is the mass of the satellite. The mass 2 is the mass of the Earth, so 5.97 times 10 to the power of 24, divided by the total radius, 6.37 times 10 to the power of 6 plus 4 times 10 to the power of 5, the orbital radius of the satellite, all of this to the power of 2. And I believe that we're going to find exactly the same value, 6,438 Newton. Okay, we have a few more applications. The next application is the apparent weight. Now, the meaning of the apparent weight is the feeling that we get when something is accelerating upwards or downwards, the feeling that we get for our weight when something is moving upwards or downwards. The apparent weight is actually the normal force that is applied on an object or on a person. Now, when we need to find the apparent weight for an object that it is on an elevator, I prefer to draw a free body diagram on the person, and since we all live on planet Earth, there will be a force of gravity, which is mass times g, and there will be a normal force that if the elevator is not moving, or it is moving with constant velocity, the normal force is equal to the force of gravity. But in this case, the elevator is speeding upwards. So there is an acceleration upwards, and this means that there is greater force upwards. So the F normal will not be equal to the force of gravity. Now, in order to find the normal force or the apparent weight, we're going to use Newton's second law. F net is equal mass times acceleration. Two forces with greater force upward, so the F net we can substitute with F normal minus force of gravity. It is equal to mass times acceleration. The normal force is unknown. The force of gravity is 75 times 10, so 750. It is equal to 75 multiplied by the given acceleration, that it is 1.5. So F normal is equal 75 times 1.5. This will be a little bit more than 110. If I'm not mistaken, 112.5 plus 750, and the result is approximately 862. So the apparent weight is 862.5 862.5 Newton. we can move on. Now, if you use the value of 9.8, maybe you're going to find a little bit less than that, but this is the meaning. We continue to a question for terminal velocity and free fall motion with air resistance. So actually not free fall motion, fall with air resistance. And when an object is falling, so it will have a speed downwards because of gravity, so there is a force of gravity that it is mass times g, and because there is an air resistance, the air resistance acts on the opposite direction. Now the air resistance has a value that it is proportional to the velocity. In this case, the force of air resistance is given 5 times v. And we need to find the acceleration when the velocity is 85 meters per second, and later we need to find what is the terminal velocity. Now, when we know the value of the velocity, it is like we know the value of the force of resistance. So this is 5 times 85. So this will be 425, if I'm not mistaken. So now we can say that the F net is equal ma, or the acceleration is equal F net over the mass. The F net is force of gravity minus the air resistance. The force of gravity approximately 70 multiplied by the acceleration of gravity, which is 10. So it is 700. So 700 minus 425 divided by the mass, which is 70. And we will need a calculator for this. So 700 minus 425 and then divide by 70. This will be just a little bit less than 4. So it is 3.93 meter per second squared. And in order to find the terminal velocity, we need to remember that the terminal velocity happens when the force of gravity and the air resistance are equal. So the F net will be 0. This means that the total force upward will be equal to the total force downward. So 5 times v will be equal to 700. So this means that the terminal velocity will be 140 meters per second. Okay. We can continue to our next question, which is about circular motion. And we have a vertical circle, and we need to find a few things about the tension on the highest point, later the tension on the lowest point, and then the speed at the critical speed at the top. So again, we imagine that we have an object that it is attached to a rope, and this object is moving on a circular motion because of this rope. So eventually it will come to this position, it will come to this position, and eventually it will be passing from the top. And we know that the speed is the speed at the top is 10 meters per second. Now, the force that it is applied at the top is the force of gravity. We can calculate it if we can, which is mass times g, which is 2 times 10, so 20 Newton. And since there is a rope, there will be a force of tension on the rope that it is unknown. However, since we have circular motion, we know that the total force acting on that point will be equal to the F centripetal, and the total force acting on the radial direction, on the direction towards the rope, will be F centripetal. So we can say that the sum of two forces, so the force of gravity plus the tension, will be equal mv squared over the radius. This means that 20 plus tension is equal to times 10 to the power of 2 divided by 8. So 20 plus tension is equal to 200 over 8. This should be equal to 25. And then this means that the force of tension is 25 minus 20. It is 5 Newton. Then we need to find what is the speed, what is the tension at the lowest point of the trajectory. If we know that the speed there, again, is 10 meters per second. But at the lowest point of the trajectory, the force of gravity is applied straight down, and the tension, it is applied towards the rope. So again, the net force on the radial direction will be equal to the centripetal force, but now we have forces acting on opposite direction. The force of tension is greater, so tension minus gravity, it is equal to mv squared over r. So again, tension minus 20. I think we have exactly the same values. So 2 times 10 to the power of 2 divided by 8. Again, the value is 25. And from this, the result is that the tension is 25 plus 20, 45 Newton. And we can say that for the critical speed that will allow the object to continue on a circle, so when the object is about to pass from the top location, what will be the lowest speed that will allow the rope to be straight? So on the object there will be a force of gravity and the tension. However, at the lowest speed, at the critical speed that we don't know, the tension will have to be equal to 0. Otherwise, actually the tension will be just a little bit less than 0. Otherwise, the rope will become slack and the object will start falling down. So the tension is just before 0. So we can say that the F net again is equal to F centripetal. The F net is force of gravity plus tension, and it is equal to mv squared over r. The tension is just above 0, so we can consider it almost 0. So mass times g, it is equal mv squared over r. The mass cancels, so v squared is r times g, so the v is equal root of rg. Root of 8 times 10 is just a little bit less than 9, so if we calculate, it will be 8.9 meter per second. And I think this will be the last question for today, where we need to find the acceleration and the tension for a system of two objects that are connected through a pulley and through a rope and through a pulley, and one of them is on an inclined plane with friction. Now, even if the question doesn't ask about this, our first job will be to draw the free body diagram. I start with mass 2, and on mass 2 there is a force of gravity. There is not an applied force towards the inclined plane, but there is a normal force from the surface of the inclined plane, and there is a tension on the direction of the rope, and we need to understand what is the direction of the motion. In this case, it's telling us that the mass 1 is moving vertically upward and the mass 2 is moving down on the inclined plane, so the mass 2 is moving downward, and this means that there will be friction acting to the opposite direction. So there is a force of friction acting to the opposite direction of the inclined plane. Now, sometimes on the AP exams, maybe we need to draw the free body diagram on a separate dot, not on the diagram itself, so we'll try to copy these arrows: force of gravity, tension, and friction. Because we have, actually I should have written F, force of friction, or because this object is moving, it is kinetic friction. Now, on the first object, things are more simple. There is force of gravity straight down and tension straight up. However, since the object accelerates upwards, it makes sense that the tension is greater than the force of gravity. So if we have to draw the free body diagram, we'll draw the force of tension great and the force of gravity a little bit less. And one more thing that we need to be a little bit careful is that the tension on the two on the two objects should be approximately equal. In reality, it should be equal. If we don't have a ruler, we need to draw it approximately equal. Now, although this is the free body diagram, we cannot really work with these forces because the object 2 is moving along the twisted x-axis. So we need to analyze the force of gravity into its two components. So we will not work with the force of gravity. I can remove it. I will work with the two components of the force of gravity, one straight down on the x-axis, the force of gravity x, which is mass times g times sine of the angle, and one straight down on the y-axis, force of gravity y, which is m times g times cosine of the angle. And the normal force is equal to its opposite, so it is equal to m times g times cosine of the angle. The tension force has no formula, but the force of friction, the Fk, is equal to mu times the normal, and we know that the normal is m times g times cosine theta. So part A, we drew the free body diagram. Part B, we need to find an expression about the acceleration. And in order to find the acceleration, we have to work for the two objects as it is one system. So the F net is equal to the total mass multiplied by the acceleration. Now, the F net is the sum of external forces, and if we look carefully, there is the force of gravity x pulling the system down on the inclined plane, the normal force and the force of gravity y cancel each other. Now, the force of tension is an internal force, so we don't care about this when we're working for the system. There is an opposing force of gravity, that it is m1 times g, and I actually made a mistake by saying that the force of gravity x is just m. I should have written m2, and the same thing for the force of kinetic friction. It is mu times m2 times g times cosine theta, and there is a force of kinetic friction that opposes the motion. So the F net is the force of gravity x minus the force of friction minus the force of gravity for the first object. And it is equal to the total mass, which is m1 plus m2, multiplied by the acceleration. So we get the value m2 times g times sine theta minus, for the mk we know that it is mu times m2 times g times cosine theta, minus m1 times g, this over m1 plus m2, it is equal to the acceleration. And the only thing that I believe we can do is bring common factor the g, so the acceleration is equal m2 sine theta minus mu m2 cosine theta minus m1 over m1 plus m2 multiplied by g. And this is the answer for part B, which we need to find the acceleration of the system. The acceleration of each block is equal to the acceleration of the system, since the two blocks are moving together. And for part C, we need to find the force of tension. Now, in order to find the force of tension, either we will work on mass 1 or we will work on mass 2, but I think that the easiest one is the mass 1, since there are only two forces applied. So we can say that for the mass 1, the F net is equal mass 1 multiplied by the acceleration. Now, on the mass 1 is moving upward, so the F net is tension minus gravity. Tension upward minus gravity downwards. So, force of tension minus m1g is equal with m1 multiplied by the acceleration. And for the acceleration, we know that it is m2 sine theta minus mu m2 cosine theta minus m1 over m1 plus m2 multiplied by g. Now the only thing that we can do is bring the m1 to the m1g to the right, so the force of tension is equal. I will try to actually apply the m1 with every single term on the fraction. So m1 m2 sine theta minus mu m1 m2 cosine theta minus m1 squared divided by m1 plus m2 multiplied by g plus m1 times g. Actually, I think that maybe I should have done that, so I will switch back to whatever I did, because the m1 later can become a common factor, so I will just say whatever we had before. So m1 fraction m2 sine theta minus mu m2 cosine theta minus m1 over m1 plus m2 times g plus m1 times g, and we can see that the m1g is a common factor, so if we want, we can say that the force of tension is m1 times g, the fraction plus 1, so m2 sine theta minus mu m2 cosine theta minus m1 divided by m1 plus m2 plus 1. And this could be the final answer. Now, thank you for watching this video. If you have any questions, feel free to write it on the comment section. Thank you.